All right, guys. Now it is time we talk about Newton's second law of motion. Now, Newton's second law of motion states that the rate of change of momentum is directly proportional to the applied force, or you can say the net force or the resultant force. And the momentum change takes place in the direction of the force. So that is Newton's second law. Just take your time to imagine this statement. You know, Albert Einstein told us that imagination is more important than knowledge. Anyway, when I thought about this statement, I say that, well, there will be no imagination without knowledge, because I think imagination depends on knowledge. You must know something before you can imagine. So now you know Newton's second law of motion. Now, it is good that you imagine the law, okay, play in real time, like in reality. Okay, now, according to Newton, he said that the rate of change of momentum is directly proportional to the net force or the applied force, okay? And the momentum change takes place in the direction of the force. And this is true because if something is stationary, you push that thing. Of course, you apply the force. Remember, before you apply the force, that thing that is stationary, it is under the influence of two opposing forces. I hope you know. Okay? East weight and the upward force exerted by the ground. You know, most of you don't know that. As I'm standing here now, the ground is exerting an upward force on me. Okay? And gravity is exerting is exerting a downward force on me. Yes, that is why I can stand. If the ground is not exerting an upward force, of course, there is no way I can stand. It's not possible. It's not possible. So when you now apply a force on something, we are talking about resultant force here. That is summation F. Okay? Now, the resultant force is what is equal to what? Mass times acceleration. This is a vector equation. That is, you add the forces vectorially. Okay? Yes, you add them vectorially. You know, I made a video about vectors, addition of vectors, even non-parallel vectors, parallel and non-parallel vectors. So it's in one of my videos. So you can go to my page and watch it. So now this is a vector equation. So this is the resultant force, summation F equal to mass times acceleration. Now, you know, it is bad after studying Newton's laws of motion, you don't like imagine the laws yourself. It is a very bad thing. You just know the equations, use it and solve the problems and go. Okay, let me tell you something. Do you know that if I fire, let's say something, let's say I stand on the top of a mountain, then I fired something, let's say a bullet, at the right velocity such that the bullet will move in a circular path around the earth. That bullet, once the path is circular, that bullet will have a constant speed, but not constant velocity. Do you understand? The bullet will circle the earth forever. Do you understand? We are talking about a speed, let's say about 8 kilometers per second. This is a very high speed, 8,000 meters per second. About is an approximate value. That bullet will continue to circle the earth forever. That is, if there is no air resistance. Do you understand? But this is not an example on Newton's first law, though it is moving with a constant speed. Okay? But it's an example on Newton's what? Second law. Okay? Because there is a force, which is the force of what? Gravity. What made the bullet to move in a circular path is because of the what? The force of gravity. Because the direction of action of gravity is perpendicular to the direction of the motion. That is, the bullet is supposed to move straight. But something made it to do what? To move in a circular path, which is what? The gravitational force acting perpendicular to the direction of what? Motion. Acting perpendicular, directed towards the center of the earth. Do you understand? That is it. So remember Newton said that a body can continue in a straight line. A body with a uniform motion can continue in a straight line, uniform motion, constant motion, unless a resultant force acts on it. So force can cause a change in velocity, but in this case, the direction is what is being changed, not the magnitude of the velocity. But this is not an example of Newton's first law, but rather it is the second law that we are talking about now, because there is a direction change. Do you understand? Yes. But this that bullet will continue to circle the earth forever if there is no resistance to its motion. Do you understand? Another thing I will tell you is about the moon. Do you know that the moon is a constantly falling object? Yes. The orbit is elliptical. Do you know why? Because its velocity is not high enough to form a circular orbit around the earth. So there are times where it will move faster and times where it will move slower, because the orbit is what? Elliptical. Do you understand? With the earth at its focus. That is, the focus of the ellipse is what? The earth. Do you understand? But the body is constantly falling. The thing is just that it misses the earth. I said this thing in my first video, that why it constantly moves is because of what? Inertia. Because of inertia. Yes, because of inertia, it will continue to move around the earth. It will continue to move around the earth. So Newton's laws of motion is something that after you read it, you try to imagine a lot of examples to help you to do what? To digest all of them. I'm supposed to take care of third law, but I will do it in my other video. Okay. There are so many examples in Newton's second law, so you can use your hand and fish out other examples. Maybe you browse about them. Okay, see you guys in my next video.